So this is the third part of the unit on solid state structures. I'm just going to quickly show you two examples of a face-centered structure and a body-centered cubic structure. So the first one we'll look at is zinc sulfide. Zinc sulfide atoms are arranged in a face-centered cubic manner. Okay, so as you can see the cube, and you have atoms of the sulfide on the corners of the cube. Okay, so there's an atom here, 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 here. These are the corner atoms. Okay, so if they're on a corner, it means that they contribute 1/8 each. And then if we have a look at the ones that are on the faces, let me try and get a different color pen. That's not going to clash too much with the green. Let's go with the yellow. And then I will draw the ones that are on the faces. So that's a face atom. That's a face atom. This one here is a face atom. That's a face atom. That's a face atom. And that's a face atom here. Okay. So you can see that there are 6 faces. Okay, remember that the ones on the faces contribute 1/2. So that means 6 times 1/2 is 3. And then the ones on the corner is 1/8. So 8 times 1/8 is 1. So 3 plus 1 is 4. So that means for a face-centered cubic, there are 4 atoms, and subsequently there will be 4 lattice points. Okay, let's have a look at the lattice points. Let me pick a different color. So let's have a look now for 0, 0, 0. 0, 0, 0 sits in this position here. This is the origin. Okay, and now we need to see where the other ones are. The next one is showing you this half in A. Okay, remember how the lattice points work. We have X, Y, and Z as coordinates. Otherwise, A, B, and C. Okay, so we now need to go half in the A direction. Okay, remember A direction is this direction as indicated over here. So it's to the right. Okay, so we go 1/2 to the right, and then 1/2 in B. B is the back direction as indicated on the little Cartesian planes. So if we go 1/2 to the right in the A direction, we go this way, and then we go 1/2 back, we end up at this atom over here. Okay, so that is the 1/2, 1/2, 0 atom position. Okay, let's have a look now at the 1/2, 0, 1/2. Okay, so this will be a 1/2 in A, no movement in B, but a 1/2 in C. So we need to go a 1/2 in A. So we're going a 1/2 in A, and then no movement backwards, but a 1/2 up. Okay, so that is this atom over here. Okay, and then the last one is 0, 1/2, 1/2. So that means we don't have any movement in A. Okay, we have a 1/2 a movement in B and a 1/2 a movement in C. So we're going to have a 1/2 a movement in B. So if we start from the origin, we go 1/2 in B and then a 1/2 in C, which means we end up in that atom there. Let me just circle this one here for the black. And that's how we determine the lattice positions for a face-centered cubic structure. Okay, now the green atoms indicate the sulfides, and you will notice that the zincs are sort of stuck in between. So they are the purple atoms that you see on the screen. Okay, and they fill what we call tetrahedral holes. You can see the geometry. of the zinc atom, if I just choose one zinc atom here, okay, you can see that the geometry is tetrahedral. All right, so they fill a tetrahedral hole, and we'll talk more about that in a later part of this unit. All right, the second example I want to do with you is a body-centered cubic structure for cesium chloride. This one is much easier to see, okay, and we know that in this case the chloride ions now sit on the corners of the cube. So the green spheres are the chloride ions, which I'm indicating as X's so that you can see. All right, remember that these guys sit on the corners, so they contribute exactly 1/8 to the unit cell. And then the cesium ion is the one that sits in the middle. Okay, so here is the cesium ion here that sits right in the center. That's one whole atom sitting inside the unit cell. So therefore the total number of atoms in the unit cell is 2. And let's have a look at the lattice points. The lattice points, we start here at the origin. Okay, so remember that this is the A direction, that is the B direction, and this here is the C direction. So 0, 0, 0 would indicate an origin point over here. Okay, and then the second lattice point is a half, 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 which means we move 1/2 in A, 1/2 in B, and 1/2 in C. So let's do that. We walk along here till we get to 1/2. Then we walk along B till we get to 1/2. And then we walk along Z until we get to 1/2. And we end up at this position here. And that is the second lattice point for a body-centered cubic example of cesium chloride.